So, I think 2 lectures earlier I had given an outline. I had talked actually in details about Brahmagupta's use of symbols and about his formation of equations, but there was not much time to talk about the very important topic of 0 and negative numbers, which I will start now. Now, one has to be very clear about one thing, the algebraic role of 0. So, therefore, I will quote a distinction which is made in history of mathematics between the 2 important features of 0. One is the notational innovation of the 0 symbol as a placeholder in a place value numeral system, like this is 2025 CE, and so when you have to write it, you can write 2 for 2000 and you can write 25, but there is nothing 100. So, at that point you put a 0. So, that is the placeholder role of 0. The other is the abstract conception of the number 0 as an integral part of a system where one can perform fundamental binary operations like addition, subtraction and multiplication. So, roughly 1 and 2 correspond respectively to the roles played by 0 in basic arithmetic and algebra. So, the first one is the arithmetical 0, the second one is the algebraic 0. Not that mathematically there is a difference between the two, these are equivalent mathematically, but it is a question of historical perspective, that how 0 was perceived. So, the point is that the 2 is equivalent to 1, but those who have given 0 as a placeholder, did they have that perception? You know, proving an equivalence is also a big thing in mathematics. So, just because 2 statements are equivalent does not mean that somebody who has realized 1 also realized 2. So, this aspect 2, that is 0 as an integral part of a system where one can perform the fundamental binary abstract, the abstract algebra aspect of 0 is central in modern mathematics with its emphasis on algebraic structures. And the fact that this aspect 2 needs a conceptual leap from aspect 1 will be clear when you look at something in history, that ancient and medieval scholars often refer to the decimal notation. You see, the decimal notation has been praised all over the world from 7th century. A Syrian monk had been talking about the decimal system, then in 10th century a monk in Spain had been talking about the decimal system, praising it. But Swami Vivekananda refers to decimal system as 10 numerals, but they did not talk about 10 numerals, they talk about 9. Indians had the way they write numbers with 9 figures. That is what the Syrian monk and the Spanish monks have been saying. So, the point is, the very fact that scholars refer to the decimal notation as a system with 9 figures shows that the placeholder 0 symbol was not perceived as a number on the same footing as other numbers. And even in India, which has given the decimal system, this perception of 0 as a number was not there always. I will give you one example. In the Mahabharata, there is an allusion to the decimal notation. So, there is a duel going on between Bandi and Ashtavakra. There is an intellectual fight. And so, what happens is that one of them sings the glory of the number 1 and the other, tries to beat him by singing the glory of 2. Then he hits back by singing the glory of 3. So, he says glory of 4, like that it goes. Then when this person, the turn of 9 comes to the person, he says that with 9 figures you can represent any number no matter how large. So, which means that the decimal notation was already there when this sloka of Mahabharata was being written. So, do not ask me when it was written, but this occurs in Mahabharata. that with 9 figures you can represent any number, right, but at that time obviously 0 was not perceived as a number, otherwise it would not have fitted in its 9, and that you see in other civilization.
The other shloka by chance?
Yes, it is in my article. The exact shloka is there and with reference that Mahabharata what number. So, 0 as an integer. So, this profound step of elevating 0 to an algebraic number, a Sankhya, was taken in India. An Indian mathematician. So, when there is a discussion on history of 0, there is this screaming that it is not that Indians invented 0, 0 was there in Babylonia, 0 was in Greece, 0 was in Mayan civilization, this, that. But it is only in India that 0 was considered as an integer among all the ancient civilizations. And the concept of 0 as an integer went from India. It is the placeholder 0 that you find in other civilizations. So, the profound step of elevating 0 to an algebraic number was taken in India. Indian mathematicians were perhaps the only ancient mathematicians to explicitly define mathematical operations with 0. So, the rule A into 0 equal to 0, you do not find it anywhere else.
This dates back to what? Elevating 0, and when did Indian?
No, that is what I am coming to, that is Brahmagupta. So, ancient Indians recognized 0 as a number in its own right, not a mere placeholder for a place value system, and ancient Indian texts include verses on Shunya Ganita. There is also a topic called Shunya Ganita, mathematics of 0, but all these things come after Brahmagupta. I mean this section on Shunya Ganita. So, they describe all the rules which bring out the ring theoretic aspect of integers with 0 as the additive identity. And the earliest text which has come to us, oldest text in the world which does this is Brahma-Sphuta-Siddhanta of Brahmagupta, and in chapter 18 in verses 30 to 35 he gives rules of operations with numbers positive, negative and 0, treating all on the same footing, and then the tradition continues.
So, that means even in Aryabhatta 0 is treated only as place value.
Yes, Aryabhatta does not have negative numbers.
Neither 0.
No, see, Brahmagupta is telling you the rules of operations with 0 and negative numbers. First of all, Aryabhatta does not have negative numbers and he does not state any rules of operations. So, this entire topic which I am now dealing with, the topic does not exist in Aryabhatta. That is why I was saying this will be there in Bhaskaracharya, but Bhaskaracharya is 1150. And the other popular book is Aryabhatta, and in Aryabhatta you do not find all these things. So that is why I am emphasizing that how much it is hurt, the cause of the history of Indian mathematics has been hurt by neglect of Brahmagupta. And this has been recognized in Bourbaki. You know, Bourbaki has several books, and one of them is on history of mathematics, and there he makes, I mean, it should be they actually, but anyway. So, our actual decimal system, which by the agency of the Arabs is derived from Hindu mathematics, and this is absolutely, I mean, Al-Khwarizmi and all the Arabs have acknowledged this to be Indian thing. It is only some modern Europeans and Indians who are not, even though Arabs have written about India, they are unable to read that. I mean, anyway, that is a different matter. But our actual decimal system, which by the agency of the Arabs is derived from Hindu mathematics, where its use is attested already from the first centuries of our era. So, this first sentence is about arithmetic, and then he adds a sentence, it must be noted moreover that the conception of 0 as a number and not as a simple symbol of separation and its introduction into calculations, that means operations with 0, also count among the original contributions of the Hindus. Now, this is a mysterious thing. So, he makes the things very clear, but when you talk about the Hindus, so Hindu civilization is a 5,000-year civilization. So, you get lost where? So, the thing is that the location is not there, it is there in, so it becomes something an existential statement. That Brahmagupta's name is not mentioned here, and therefore, this becomes a myth. And when you come, where is there? Is it there in the Vedas? Is it there in Aryabhata? It is not there. So, it does not exist. So, precise text is not mentioned, author is not mentioned, date is not mentioned. And this happens, I mean, I am not talking about Bourbaki, I mean somehow when it comes to Indian mathematics, the word Hindu takes care by the objective authors, like for example, about fractions. All the textbooks, Roger Cook, History of Mathematics, he mentions that it is the Hindus, I do not know whether he said Hindus or Indians, but whatever, that they have given rules of fractions, doesn't mention who gave. Now, as far as negative numbers are concerned, this is another tricky topic, because what we do not realize is that this negative numbers was taught to us, was told to us as rule when we were too immature, and we, those who studied in school, we did not invent negative numbers. But negative numbers we have learnt in either class 6 or 7 or maybe even in class 5, and therefore, we think of it as a very basic topic. Anybody could have done that. But decimal system we learned even earlier, but decimal system has been very loudly proclaimed as a great invention. Negative numbers has not been talked about that much, and therefore, I am giving this quotation from Klein. Klein is not talking about the invention, greatness of the invention. This passage occurs in his book on mathematics education. So, he is giving a warning to mathematics teachers that note that this requires a high order of abstraction. So, basically he wants to say that be compassionate to students. Okay. That is the context in which he is saying. Let us realize, so this is not a book on history of mathematics, it is on mathematics education. Let us realize once and emphatically how extraordinarily difficult in principle is the step which is taken in school when negative numbers are introduced. Here for the first time, we meet the transition from concrete to formal mathematics. The complete mastery of this transition requires a high order of ability in abstraction. And since many of us, since some of us are involved in the new textbook writing of the NCERT thing, and some of us in the audience were actually involved in the writing of negative numbers. So, when we physically met in CMI to discuss the plan of writing negative numbers, actually not negative numbers, but class 7 textbook. So, that some film where Amitabh Bachchan is there, then he becomes a scene stealer, that you don't have the occasion to watch others. So, similarly what happened in CMI is that this negative numbers became the scene stealer that we made for, I do not know, 3 or 4 days. Most of the time was went in debating negative numbers, how it is to be introduced, this way or that way or that way. So, there was an experimental proof of this Klein statement. It requires a high order of abstraction, and therefore, there was a complete, it was like a parliament when it came to negative numbers, parliamentary debate. Now, so what I am trying to say is more seriously that learning it is a concept which is already in existence. Learning it is saying it has high order of abstraction. Then how much abstraction was involved in its invention? So, we now give the statements, see how many statements are there. So, very systematically, addition, then subtraction, then multiplication, then division. So, today I will restrict to addition, subtraction, multiplication. So, Brahmagupta says the sum of two positive numbers is positive, of two negative numbers is negative, of a positive and a negative number is their difference, and if they are equal, it is 0. The sum of a negative and 0 is the negative, of a positive and 0 is positive, of two zeros is 0. So, Brahmagupta is relatively terse, and Sripati clarifies that what he says, what is meant is that the sum of a positive and a negative number is the difference, and the sign of the difference is a sign of the greater. Now, what you have to note is here that Brahmagupta is introducing something new and very clearly introducing to. So, here he is very careful. So, the problem is that one can always add 2 and 3 and get 5, that is not the issue, but the issue is what will be the sign. So, plus 2 plus 3 is plus 5, that is okay, but suppose you have minus 3 plus 2. So, with 3 and 2 you can do various things. I mean, that is not the issue, that what will be the number, but what will be the sign which comes there. So, the first statement is that the sum of two positive numbers is positive, and the sum of the, but that is obvious, but what is probably not so obvious is that the sum of two negative is negative. So, you have minus 5 and minus 3. So, 5 and 3 will make 8, but what will be the sign of that? So, his focus is on that what would be the correct sign. Now, if you have to write symbolically, then the thing would be that what he is talking about is plus a plus b will be plus a plus b. You can say that he is not saying that plus 3 plus 5 is plus 8, that is not really said here, but that is understood, because as you know the focus is that what is the sign that should go with 8. So, if you write in symbols and then his statement comes to, so again I am repeating the statement that suppose a and b are positive for clarity, then what he implicitly says is that plus a plus b is plus a plus b, minus a plus minus b is minus of a plus b, plus a plus minus b is plus of a minus b if a is bigger than b, and minus of b minus a if b greater than a. This clarity is coming from Sripati. Brahmagupta is admittedly terse.
What was Brahmagupta's motivation for studying negative numbers, or how did he conceive negative numbers as what, entity, solving some equations?
No, Brahmagupta, as far as this section is concerned, he does not give the reasons for doing it, he just gives the rules and then just goes ahead.
Think of negative numbers, to start with that, just as an abstract notion, or?
The entire chapter, the entire algebra chapter is abstract. So, the whole point is that this would be speculative, because Brahmagupta, since Brahmagupta has not given the reasons for doing negative numbers, whatever answer one gives is would be one speculation. But one informed speculation, I would have told it in the next lecture, but since the question came up, let me hazard a guess. The term for positive number in Brahmagupta is dhana, and the term for negative number is rina. So, it could have been various things, but it is dhana and rina, and dhana and rina are concepts coming from accountancy. And there was a strong culture of accountancy in India. One text which has captured the imagination of people, that we had such a text, that is Arthashastra. So, Arthashastra has various things, but one dominating thing is accountancy. So, since there is so much Arthashastra is not teaching you positive or negative numbers, but its impact was it was an impactful text in Indian tradition, and since Brahmagupta is using the terms from accountancy, one can say that that would have been the inspiration. So, this is just a guess, one cannot give a rigorous proof of that. And mathematically what you find is that he must have realized the simplicity that would come up when you introduce negative numbers, because the motivation for the chapter is the solution of the linear indeterminate equation, that is a x minus b y equal to c, to be solved when a, b, c are a thing. Now, Aryabhata uses only positive numbers, and therefore, it creates a hardship. And the thing is that allowing negative numbers, that gives you more flexibility. So, Brahmagupta would have realized that. The other thing is that something like quadratic equations. So, quadratic equation is a very ancient topic. It is Babylonians have solved quadratic equations, but how they solved? They solved it numerically. So, given an example, they would give you the answer. Though the method of doing it is really the modern method, so the so-called Sridharacharya method, but the thing is that it is not stated in that abstract formulation, algebraic formulation. It is stated through examples. So, Aryabhata has solutions of quadratic equations also, but in specific contexts. Now, if you look at the Arab treatment and early European treatment, even in 16th century, the treatment of quadratic equation, they used to consider several cases, ax square plus bx equal to c, because a, b, c are all positive, ax square equal to bx plus c, and look at all such possible combinations, whereas Brahmagupta gives you the single formula. So, a, b, c can be negative. So, the conciseness that you gain by introducing negative numbers, Brahmagupta must have realized that. Yeah. So, the point is, as I am saying, that this sentence implicitly gives these rules. Now, again, let me again repeat what I had said last time, that Brahmagupta had very clearly talked about using symbols for unknowns, and Prithviraj Swami had given elaboration that how to use the symbols. However, when it comes to presentation, then it was the convention of the time, and that convention was there in Europe as well. If you look at Fermat, I mean how he poses the problem, all problems are posed verbally. You see, the verbal thing, it has a certain charm. I mean, you think of something like nx square plus 1 equal to, solve nx square plus 1 equal to y square. It does not really make much sense. Why should one do that? Whereas, when Fermat states it verbally, that can you think of a number such that when you square it and add 1 to it, it becomes a square. So, the whole point is that something which is not a square, by adding just something which is not a square, when you multiply it with a square and just add 1, then it will of course can't be a square, but just by adding 1 to it, it becomes a square. So, if you say it in words, then the point of the problem becomes clear. Whereas, solve nx square plus 1 equal to y square, it requires a mathematician to even appreciate that why one should do that. So, it was the convention to state things verbally by the masters, and it is the commentators in the work in commentary you see symbols like Bhaskaracharya, Lilavati and Bijganit, these are beautiful poetries, everything is written in words. But when you see his own, he has written commentary on his work. So, there it is symbols. So, this kind of things, this Brahmagupta's what he has written, all these things, that people will use to show that what Indians had was rhetorical algebra or as most syncretic. They did not have symbolic algebra. These quotations are used. So, one has to be careful that in fact, when I was writing my a paper to be submitted to a journal in TIFR when I was immature. So, I gave the title on subalgebras of Rx1, X2, on R subalgebras of Rx1, X2, Xn. So, when I showed it to senior expert, he says that this is not the way to write a title, R subalgebra of Rx1, X2, Xn. You would write R subalgebras of polynomial algebras. So, that is the title of my paper. one of my earliest papers. So now will you say that the TIFR people didn't know symbols? The TIFR people did rhetorical algebra. So everything is done in symbols, but when you submit the title, at least title should not have symbols. This is modern convention. Government report, send it to government what you have done in your institute. It, as far as possible, avoid symbols. It's a 21st century convention. Then you comes to subtraction. So if a smaller positive is to be subtracted from a greater positive, the result is positive. If a smaller negative is to be subtracted from a greater negative, the result is negative. If, however, the greater is subtracted from the lesser, that difference is reversed in sign. Negative becomes positive and positive becomes negative. If a negative is subtracted from 0, it becomes positive. If a positive is subtracted from 0, it becomes negative. If 0 is subtracted from a negative, the latter remains negative. If 0 is subtracted from a positive, the latter remains positive. 0 subtracted from 0 is 0. A huge elaboration. So, in symbols, all possible rules for subtraction between the signed numbers, all possible cases are dealt with. Then multiplication. The product of a negative and a positive is negative, of two negatives is positive, of two positives is positive, the product of a 0 and a negative, of 0 and positive, or of two zeros is 0. So, minus into plus is minus, minus into minus is plus, plus into plus is plus, 0 into anything negative or positive or 0 is 0. So, full details are given. So, even now when you talk that we should explain why minus into minus is plus. So, what we have in mind is minus a into minus b is plus ab, but we really do not talk about this a and b is ab. We say that you have to give a motivation why minus into minus is plus. So, the Brahmagupta is talking in that why negative into negative is positive, but then taking it and then pointing out, but he is not saying minus a into minus b is plus ab. He is saying minus into minus is plus, but does not say minus a into minus b is. So, this kind of hair splitting does not make sense. You just inspect that how you yourself talk. We talk about minus into minus is plus. So, some of Brahmagupta's rules on operations involving 0 may be summarized in symbols. So, I am just picking up something which would look familiar to us, that a minus a is 0, that is very clearly stated. A plus minus a equal to minus a plus a equal to 0, whether a is positive or negative. So, I am giving it as a summary. A plus 0 is 0 plus a is a, 0 into a is a into 0 is 0. So, he is imparting ring structure on integers, which 0 is the additive identity.
The distributive law mentioned, or
which one?
A plus b times c, ac plus bc, if that is to hold.
That is older actually.
That is to hold, then this minus times minus is plus, etc. That is explained so that the
distributive law already existed. Brahmagupta is not giving any justification. The justifications are coming later. Much
distributive law for positive numbers is clear.
Yeah.
Clear or understood. But if the same law is to apply also when a and b are positive or negative, that will justify something like 0.
No, but then but that you are actually you are thinking it of as an axiom, because it's a circular thing that why distributive law holds for a positive or negative.
Okay, that is the way we explain now. In algebra classes we explain.
No, we see in algebra, in modern algebra, what happens is that a into b plus c is taken as an axiom. The distributive law is taken as an axiom for ring. And regarding integers and such things, why the distributive law holds for a and b, I mean that is something I do not know whether we have paid sufficient attention to that. I mean that is a that's a gray area, because in school we were not so rigorous about such things, that what is really assumed and what is being proved. And then when we come to college, we have this simple option that take this as axiom, then nobody can question anything. So, so the historical perspective about this mathematics with zero and negative numbers. By the way, there is also division, but this division will require a separate discussion. Therefore, I am postponing it.
Is there anything like minus of minus a in those rules?
Yeah.
Minus of minus a is plus a.
Minus a square is plus a square.
Minus
Negative of minus a is plus a.
Yes,
That was
that is there.
This binary thing.
See, 0 minus of minus a, that practically is what you were asking. So, that is very clearly stated. So, let us look at the exact statement. If a negative is subtracted from 0, it becomes positive. That is minus into minus, I mean that minus of minus is plus, that is a statement out there. Yeah, so just to conclude, the history of the conceptualization of 0 as a number amenable to the fundamental operations, so these are my comments, is closely and symbiotically related to the emergence and recognition in India of algebra as a distinct branch of mathematics. This goes together. So, in BSS is the abbreviation for Brahma-Sphuta-Siddhanta, is Brahmagupta's main text. So, Brahmagupta compiles a separate chapter on certain topics that we now recognize to be algebra and emphasizes its importance. In the process, he makes a conscious formulation of the science of algebra. Now, when he is doing that, I had said it before, but I want to emphasize that after a statement, what was his first statement in this chapter? That was about the indispensability and power of the subject matter, and that I had elaborated in one of the previous lectures. And then he gives a list of the core topics of algebra chapter. So, he defines the scope of algebra, but after that introduction, what is the first topic he mentions in the list of topics which comes under algebra? The very second item in Brahmagupta's list. So, I think the first item is that Kutaka. The second item in Brahmagupta's list is the 0, negative and positive quantities. So, the importance that he gave it to be that this was at the top of his list of topics that in the chapter. And conversely, so in retrospect, one may say that the emergence of the 0 as a central object in a number system was the outcome of the algebraic mentality of the Indian mathematicians, which was sometimes dormant and sometimes in the open. And conversely, the comprehensive treatment of 0 and negative numbers, which I have partially illustrated, was an important pillar in the foundations of algebra laid by Brahmagupta in this chapter. And there is no such thing till very recently in Europe. I mean, Al-Khwarizmi, for example, does not have such a discussion of negative numbers and 0. I mean, he has discussed 0 only in that arithmetic sense. Oh, okay, I think that is because the next topic is very subtle, division. So, therefore, division will be discussing separately, because that is also a controversial topic.